So welcome everyone to the IETF 114 meeting of the Quic Working Group. If that's not where you expect to be either physically or digitally, then I would hurry on over to where you're supposed to be. So some things, it's Thursday now, so everyone's probably used to this, but remember the importance of the IETF Note well. This is a copy of it. I'm sure you've seen it. If you need to find references to it, it is very easy to find, both on the IETF website, but also Googling anything related to IETF Note well. It's a fairly unique name. So for some IETF meeting tips, in-person participants, you're probably used to this by now, but remember to use Meet Echo Lite when you are in the room. This is useful for us chairs to keep track of the queue with both remote and in-person participants. And also we want to stress that those there in person should be wearing a compliant mask at all times. There are N95 masks available at registration. Please remember to keep your mask on. And remote participants, the normal applies for making sure your audio and video are off unless you're, presenting. And we do recommend using a headset and or checking, making sure your levels are good on your mics. So Administrivia, we have our tireless volunteer and Robin Marks, who is volunteered to take notes, and we thank Robin yet again. The blue sheets, this is again being handled through Meet Echo. Remote participants doesn't have to do anything. Those there, again, please use Meet Echo Lite. For chat, we are of course using Meet Echo and Zulip. So, and for the queue, the chairs, despite our remote and arguably larger than life presence, we will be running the queue with the assistance of Zahed, who is, you can see up there in person. Thank you, Zahed.
Matt, just to jump in quickly there, sorry. We did have Brian volunteer to take notes as well. That's great. Okay. The more the merrier. If somebody in the room would just like to assist the remote note takers, that would be greatly appreciated. So do dive into the notes and contribute where possible. I don't think we had anyone volunteer for JavaScribe though. Would someone like that job? Just in case we need to augment anything to the mic. One of us could probably do it too. But...
shall I do that?
Jonathan, that'd be very helpful. Thank you.
All right.
Thank you.
Thank you all who are helping us run this meeting. All right, so agenda, which can be bashed. So we have chair updates as usual, which you'll have to suffer through. And then we have 3 working group items. The first and longest is multipath, followed by the acknowledgement frequency work, and then Quic LB. After that, we have other items, including Quic timestamps, multicast Quic, and talking about Quic analysis tooling. Martin, would you like to say something?
Yes, Martin Duke, Google. Kind of an agenda bash, but like rather than actually introduce another presentation, I would just like to briefly say that I think most people are aware that Lucas and I have a draft to put Quic versions in alt service and DNS service B records as we dissociated ALPN from Quic version. In HTTP BIS today, they're likely to dramatically strip down alt service and not have parameters, and become service B would be the transport capability discovery mechanism. The upshot of that for this working group is that we will likely accordingly strip down our draft to just Service B, and the place where Service B stuff lives is in the protocol working group where it applies, which means we'll likely be bringing this draft to Quic sometime in the next month or two. So look for that, and we'll probably call for adoption relatively early, since it's a simple mechanism. Thanks.
Thank you for that, Martin. Is there anyone else who would like to agenda bash or otherwise have a note of order here? And if not, I will move on to, Miria. Or Miria is, okay, Miria is not ready to go. Okay, update since last meeting. As probably everyone hopefully noticed, and if you didn't, I have great news for you, which is that HTTP 3 became an RFC at long last. And of course, another document, which is QPAC related, of course, is, yes. This is obviously a big milestone. They lagged considerably behind the other Quic documents for reasons that are not really worth going into, but we no longer have those on our plate, and they are RFC'd where they can live in perpetuity. So, and then other updates, the Quic respit, which is a very simple, a relatively simple document, but important one, is currently in auth 48. And version negotiation in V2, which are sort of proceeding together as was agreed, are currently under AD evaluation. So other things, we had issued an adoption call and it completed for the Quic careful resume. This got some feedback about its potential suitability for other potential working groups, specifically the discussions around congestion controls life at the IETF. So the chairs are going to take this under consideration. QLog is not presenting today, and this is not due to a lack of progress, but they are so, and expect a new draft for before 115 and updates to be on the list. We'd also like to call out that L4S, which you may have heard about at this IETF, work was done during the hackathon, including interop that with Quic stacks, which is very exciting because Quic is participating and working with L4S with the L4S work. And I think that is it. Lucas, do you have anything else that you would like to add to our Mooring Chair updates?
Nothing major, just that Matt and I were both really excited to be there in person this time round, to actually meet each other for the first time in however many long, and meet all the participants as well. Unfortunately, we can't be there for various reasons. So thank you very much for your patience and support to people who've been helping behind the scenes to make sure this session can run smoothly.
I agree with that, of course. And now we will both stop talking, and we will allow Miria to take over as the first presenter. And my Meet Echo is totally not allowing me to do anything, so that's interesting. Okay, I got it to work.
Try it again. Ah, no. There we go. Okay, hello everybody. My name is Mir Kühlewind. I'm one of the editors of the multipass extension for Quic, but probably the least important editor, but I'm the only one here, unfortunately. Yeah, so we published a new version, and this was actually quite a big update based on the discussion we had last time. The biggest change is that we merged the PR, which has what we call unified proposal. We discussed this last time, and I have a slide later on this. And there were some other few changes that I want to update you on. One is that also an issue we discussed last time, that we now decided to have some mechanism to also signal that there might be, or that you want to use one of the paths only for standby modus, and we have a new frame for that. There's some clarifications about path closure or like denying a path, which is also actually kind of new protocol work, so I will go to that. And then more guidance about ACK scheduling and delay calculations, but that's also kind of still work in progress because that's some of the hard parts. Yeah, we didn't solve or we didn't close all the open issues. We still have 3 of the open issues that we discussed last time. So these are need a little bit more work, especially the first one. It's on my plate to look up what we actually decided or like why we didn't allow servers to migrate and if that's still important for multipass. So I will do some research and come back to that. Just didn't do it now. And the other ones are also looking for more input about like the actual need for these things. So for all of these 3 open issues here that we discussed last time already, we have to figure out if this is something we want to do at all, if this is something we want to do in the space draft, or if this is an extension in the future. And that's ongoing, that discussion. We have also a few new issues. But I have to say these are a little bit more on the editorial side, I think. So like not fully, but as I just said, there is more work needed about explaining how to calculate ACK delay correctly. And maybe some of this is kind of normative, but it's not clear yet. So that's ongoing. That's the 2 new issues listed here. Yeah, so especially, you know, what's, I wanted to explain the problem quickly here, but not sure if we will solve it completely or finalize the discussion here. So the problem we have is if you, and there's still a part about using single packet number space. So if you use single packet number space, then things like calculating your round trip time and delay correctly, what you need for congestion control, is actually not that easy. And this is just giving an example here. So you assume you have 2 passes, and pass 1 is quicker or faster, has less delay than pass 2. And you decide somehow on your packet scheduling, you send packet 1 to 10 on pass 1, 11 to 20 on pass 2, and then 21 to 30 on pass 1 again. So what can happen is that you receive all the packets on pass 1 because that's a faster pass. But then, because depending on like how you decide about your ACK strategy, you actually trigger an ACK when you arrive, when packet 20 arrives. So that's the packet that triggers the ACK. But of course, that ACK will acknowledge all of the packets, so 1 to 30. And when you receive that ACK, actually you don't know that packet 20 triggered the ACK. So you might not know how to calculate the round trip time or the delay of each of these passes correctly. Because packet 20 was sent on pass 2, but like 2030 was sent on pass 1, but the delay you basically calculate based on the ACK is the delay of pass 2. So that's like usually what's happening is like you get the delay if you just do like whatever you do with would do today with ACK calculation, you get the delay of the longest path and not the delay of the shorter path. So you have to be smarter about this. You have to either add some more information to the ACK about saying like which packet does this delay information belong to, or you have to split up your ACKs in a smarter way, or you have to schedule a packet in a smarter way, or whatever. And that's a discussion we're still having. And my phone goes to sleep, and now I cannot. Oh no, I can control it again. Okay. Yeah, so that was just to explain the problem, and I think we should have the discussion actually on GitHub, because it's not like we need to change something, but I think we have to be clear about what the best way to do. Then a quick review about what we've merged already based on the discussion from last time. So this is the new path status frame. The path status frame has like this path status information, which is the important part. And what we specify is really you have two choices here, standby or available. And what it does, it just really gives a recommendation for the other side what to send on the path. It doesn't tell anything about what you are planning to do on your side, right? But you give some hints to the other side that it's preferred from your point of view to use one or the other path or to not use it. And that's it. And then effectively, it's also just a recommendation. Of course, if there's a situation where you can only use one of them, you have to make a local decision. Okay, I go on. So the other thing we merged, which is a normative thing here, is that we other than for RFC 9000, where basically if you have a migration event and you don't want to have the new path, you just don't react. We actually give an option here to actively deny a new path by using the path abandon frame on the existing path. So this is just because we have the path abandon frame, we can make use of that, and that can just like avoid some delays. So it's like a little change, but it can help in some situations to optimize. I go on. We can come back to this. Okay, and so this was the biggest merge we have, and this slide is mostly a recap, slightly modified recap, but mostly a recap from last time. So the big question we discussed last time is like using single or multiple packet number spaces, and like there are pros and cons on both sides, right? So one of the biggest difference was like single packet number space does support zero length connection ID, and multiple packet number space does not. And that's the most of the discussion we had last time. From a code complexity point of view, there are kind of pros and cons on both sides. Like on the first look, like single packet number space seems to be much less code and much easier for that point because you don't have to introduce a new packet number space. But then if you look at this like delay calculation issues, how to get congestion control right, making sure you schedule the packet in a smart way that your X size doesn't grow and whatever, it gets very complicated. And it gets like, it's not like, there is a normative way to handle it. It's like depends on the implementation how to do this right, so it's easy to get it wrong effectively. So I think there was like a lot of support from a complexity point of view to actually go to multiple packet number spaces because that makes the spec just more clear. There is still a discussion about hardware offload because there's also implications here. So with multiple packet number spaces, you actually have to change the crypto part, how you decrypt the packet number, because you have to consider the congestion, the connection ID. But on the other hand, if you have multiple packet number spaces, it's actually easier for your hardware offload because then you know exactly, you don't have to decrypt like, you don't have to guess the packet number because you can much better figure out where you are and you don't have a lot of out of order packets effectively in these kind of things. So there are also pros and cons here. So so this is very much nearly the same slide as I presented last time, and we just merged this in now, which means basically multiple packet number spaces is now mandatory. So if you negotiate the multipass extension, you have to support multiple packet number spaces, but it's optional to use zero length ID, connection ID. If you want to use zero length connection ID, you also have to implement all this other stuff. And then it gets complicated, and we put a lot of guidance and discussion in the document about how to do there and how to get your delay calculation, your ECN handling, your congestion control right, but it's kind of optional. If you don't support single packet number space and the other end requires you to use zero connection ID, basically you can only use one path, even if you have negotiated multipass. But like there's no obligation to implement it at least. Ian.
It took me that entire, Ian Sweat, Google, it took me that entire time to get into the queue and get the page to load. Can you go back to the last slide? I have a just curious question about hardware offload. Is there available hardware offload that is for Quic today? Because I've looked into this and I haven't actually found it. And you might be right that it makes hardware offload more complex, but it really depends on what the hardware offload API is. And so like, I'm not personally familiar with them. I don't know, maybe this is much more widely available than I think, and or maybe you're anticipating future hardware offload that will exist.
So, okay.
So yeah, we should talk more, Ian. That was my issue a while ago, and it is speculative based on conversations that I've had with hardware vendors in the past. The issue 25 is kind of, but no, there's certainly no hardware offload that certainly I was aware of when I filed this issue. It was just concern that by messing with the crypto algorithm, we're going to have this other mode for multipath, which might not be a very viable thing.
So there is no hardware offload, which is I think already deployed. But we did some research and we had some work about trying like how to implement hardware offload, and we only went for the multiple packet number space solution because you don't have a lot of packet reordering, whatever, which makes your offload engine actually easier. It's different than what's today in RFC 9000, but it would make it easier if we have multiple packet number spaces. And given it's not deployed yet, that might actually be a reason to go there as well.
Yeah, I mean, I don't think this is a showstopper at this point, but it's something to consider. And
Yeah.
like, if we do have a thing where like you need special hardware to do multipath, it's probably bad for multipath.
No, you don't need special hardware to do multipass. It's just like you have to optimize. You have to have, or you can do less with RFC 9000, and you need more if you want to support multiple packet number spaces. But it's the same logic. It's just like an extended logic, right? It's not like you have two different paths to go for.
Okay,
Yeah.
thanks.
Okay, so yeah, we merged it.
I was in
So,
the myself. So just wanted to point out chair hat off on the hardware offload thing. No, yeah, again, there's no hardware offload. The hardware offload that we have been working on, the vendors involved would probably not like multipath anyway, because they typically are not happy about the hardware doing anything related to Quic that's complicated. They don't like packet numbers either. So I would say that it probably is true that the multiple packet number space is a little bit easier to support well, but it's also going to vary depending on the vendor you talk to, like what their opinions are on what is hard and for their hardware. Because what's interesting about this is that different hardware can do different things easier than others when it comes to crypto offloads and Quic in particular. So it's probably a concern, but I'm not sure that it's something that necessarily has to be designed into the protocol or taken as a major concern.
yeah, so I mean, there is this issue in GitHub, and it's still open and needs more discussion, but I don't think the decision is clear in which direction we should decide here. Christian.
Yes. Good morning. Yes, regarding this hardware, it's really the encryption issue. I mean, we cannot have multiple number space without injecting more than the packet sequence number in the encryption. So that means that your whatever offloads that has to be aware of not just the connection ID in the incoming packet, but the sequence number of that connection ID. So that's conceptually a really simple fix in the API, but it has to be there. This should not be I mean, if people can actually do hardware offload and extract the sequence number and things like that, the additional step to support multiple number space is not that high. It's just that there are tools. I mean, you have to extract 32 bits of the sequence number of the connection ID, and you have to use 96-bit sequence number, which is composed of this ID and the 32 and the 64-bit of the packet. So it does change the API. It doesn't change the complexity very much because you need the CID anyhow. Otherwise, you're not able to find the context of the connection. And if you can find the context of the connection, you can find the keys. So, I mean, the complexity should not be a showstopper there.
Jana.
Hi. So I want to emphasize a couple of points that just both Matt and Christian said. But one of the things when thinking about hardware offload is people typically use the TCP model to think about it, and which is why sequence number seems like an attractive thing to consider handing off to the offload engine. It's not necessarily true, and in fact, to be true in the Quic case for a number of reasons. One of them being that we don't necessarily expect sequence numbers to be sequential. We want to have gaps. We want to be able to do various things with sequence numbers. That's in fact part of the protocol, I would say, philosophy and even the design that our packet numbers are not basically stream numbers. Stream ID and stream sequence number, sure, that's fine, but not at the packet level. We don't necessarily need it to be sequential. We don't need it to be in any particular order. The sender ought to be able to send in whatever order it cares, and the receiver is able to handle it. That's important. And so I would say that going forward, again, to Christian's point as well, that something explicit needs to be handed down. It's very likely to need to be handed down to the offload engine from the Quic sender, and it is not something that you can simply offload as a task to the offload engine. So I don't think that sequence numbers should play a role in how we decide. Sorry, hardware offload should not multiple or single packet number spaces.
So the problem is you want to decrypt the packet number, and how you decrypt the packet number depends on the packet number space, right? So that's the part you want to do in offloading. No.
Martin Duke, Google. At the risk of going down the hardware offload rabbit hole, like the encryption and decryption problems are quite different. The encryption problem, yes, absolutely, you just pass the packet number with a packet, and I think it works pretty well. On the decryption path, the hardware needs to keep some state, obviously, because it has to, predict the expanded packet number. It has to expand it from the truncated packet number. So that's like a harder problem, and it becomes even harder with multipath. But right, if you build the APIs right, it doesn't matter. It's just a question if vendors will find it worthwhile to implement the APIs. And I don't have an answer to that.
Okay. I go to the next slide, which is my last slide, I think. So we merged in this proposal, again, saying multiple packet number space is mandatory, single packet number space is optional to implement, basically. And there's some more editorial work here because like the way it's structured in the document doesn't make that fully clear yet. But it's really just editorial work that we will do. We have some remaining issues, but as I said, again, for all of these issues, we really need to decide if they should be addressed in this document or in an extension. What's the part of the base document that we want to discuss? So it's like, I don't think it's like hard to find a solution to this problem, but it's just a decision of what we want to do here or later. And then the most important part is that we really want more implementation experience. Because if we all end up only implementing multiple packet number spaces, maybe we don't need single number packet space. Or if we actually think that zero length connection ID is not that important, we don't need single number packet space. Or maybe there's additional considerations for hardware offloading that actually changes our mind. So I think these are the open questions, and what we need is implementation experience.
Eric Kinnear, Apple. Just a really quick question about the path abandon stuff. Is the expectation that the old path receive both a path challenge and a path abandon at the same time, but we still want those to be separate frames?
So you try to open a second path and start the path challenge process. And if you don't want to accept that, you don't have to reply to the path challenge, and then there's no path, right? So that's what we already have today. And just like to avoid this time where you like time out until you get like a challenge response back or not, you can on the other path that's existent, if you have multiple packet number spaces, you can send a path abandon and just give like a explicit signal that you will not reply on the other path. Right. That's it.
But when you first initiate that triggers a challenge to go down both paths, right? Because it needs to be validated in both directions. So the new path is going to be getting a path challenge saying, hey, is this actually working in this direction? But the old path is also going to do so when it sees someone coming in from a new place.
You're saying the old path is also sending a path challenge?
Yes,
Why?
That is my understanding. That's sitting in the middle of a different section of our C9000. Essentially, it's for when the off-path attacker forwards some packets, you confirm that on the existing path.
Okay.
So the reason I bring that up is, A, it's interesting to get both a challenge and an abandon at the same time. The abandon refers to the new path, so that seems okay. It might also be possible to just like put in the challenge, like, hey, I don't want this other one.
Yeah, so the abandon only works if you have path identifiers.
Yes.
And because you don't send it on the same path. And like, we should look up this part you're just citing, because maybe that doesn't make
Well,
exactly
it may
sense.
also have been overridden by some of the new text, so I should go double check.
Okay.
Cool. Thank you.
Alessandro Ghedini, Cloudflare. We're starting work on multipath right now, and My current impression is on the single path versus multiple packet number spaces question is that the single packet number space doesn't really give us much benefit, and implementing both is kind of annoying. So we might end up just implementing the multiple packet number spaces. We might reconsider later on after we actually deploy the whole thing, but that's my current impression at least. Yeah. It's not super clear what the benefits of implementing both are, and a quick implementation kind of needs to support the non-zero connection ID case anyway. So you have to implement multiple packet number spaces, and the single packet number space is just, I don't know, more complexity for not much benefit.
So this is exactly the point. So like if you don't need zero length connection ID, that's probably additional overhead you don't want. But like we are looking for people who actually have a use case with zero length connection ID. And I mean, one of the benefits is like you save a few bytes, right? So that for some use cases that might be really important. And like there are two options here. I mean, one option is also we could try to treat the multiple packet number space solution to support at least zero connection ID in one direction. There has been proposals, but it's also like some additional complexity. It's not clear if it's needed. The other option is also like put the zero length connection ID support in an extension or whatever. But yeah, that's the feedback we're looking at.
So I think the zero connection ID case is mostly a client use case, maybe. I think some browsers use zero connection IDs. So supporting on only one side might be okay.
Yeah.
But then I guess someone who's actually using that use case might command more.
That's what we're looking for.
I think Lucas is next.
Hey, yeah, I don't need to queue. I'm the chair. I could have just interjected, but I thought it'd be polite. We've had a few comments in the chat about mask wearing. For anyone that was maybe not in the room during the initial chair slides, this is a requirement of your attendance to wear a mask at all times during these meeting sessions. So please take this seriously. This is important for our health. We all want to be able to go home at the end of the week. So thank you very much.
Thanks, Lucas.
Thanks. Ian Sweat, Google. I was more of a single packet number space fan as an individual, but I have to say that requiring both seems worse than just requiring multiple packet number spaces. In terms of zero length connection IDs, the use cases I think probably could be preserved. So like, for example, there are cases when Chrome will open 2 different ephemeral ports at the same time. And so Chrome would have like 2 different sockets, and I would think it would be perfectly easy to distinguish which path a packet arrived on based on the socket it arrived on, things like that. So that's my general comment, but I need to go back through and kind of look at all the discussion about like how you ended up where you did and make sure that I kind of understand everything that happened.
So I don't usually stand up just to say +1, but there weren't that many people who were super into just a single packet number space, and I was originally one of them, and I would strongly agree with Ian that having both seems strictly worse than having one or the other, and having multiple packet number spaces based on the things that we've been discovering as we go to implement is seeming more and more attractive.
Me again. So to be clear, I'm not implementing this, but to me, the attraction of the single packet number spaces to like not write a lot of code and get like cheap multi-path, cheap in terms of coding effort. But if we're going to require multiple packet number spaces, then like that's you have to pay the entry cost. Like the point of single, it seems much weaker to me.
Yeah, and I think this is actually kind of a wrong assumption because it looks much easier from the first place, but then actually getting all the packet scheduling, delay calculation right, and so on, it might be actually more code in the end, and it's code that is kind of not well specified in the end. So you end up with like having different implementation doing different things, and then because the other end is doing something weird, your performance goes down and you don't have any control.
Yeah, certainly optimizing it would be a lot more code, but I'm thinking just like if people wanted really minimal support, that would be attractive. But
so it's not only optimizing, right? It's really just like the delay calculation example showed this. It just doesn't work correctly. It's like it's giving you some crap, and like, yeah, if you just want to make sure you can send one packet from here to there, it's fine. But if you actually want to do the right thing, it's you cannot ignore it.
Okay. Well, if the coding simplicity is like illusory, then like to me that destroys like the case for single packet number space entirely.
Yeah.
Thanks.
So I mean, the point is, multiple packet number spaces don't support zero connection ID in both directions. There is a way, there are proposals to, so if we need this use case, then we need something, right? If there is a way to maybe support zero connection ID in one direction, but it's also giving you more complexity and more ambiguity. So like, it's also additional code. So it's really the question, what do we do with zero connection ID? Is it a use case we want to support or not?
Ownership reliable. Like many other early implementers, we are leaning towards multiple packet spaces. And the one, if we're having trouble finding current evidence that zero length connection, that single spaces are needed today, we may consider emulating zero length CIDs by injecting a known constant and essentially making it a non-zero length, and hence injecting that problem space into the other.
Hi, Luke from Twitch. I'm noticing in a few working groups that there's this tendency to put a context or like a packet space ID in to distinguish between sessions. Mask has it. Web transport, we're talking about a session ID, and here we're trying to put the path in there. I'm wondering if overloading the connection ID is the right approach. Is this something we want to do for like making load balancing more difficult, or do we want to make this part of the Quic API, like just literally put packet space in the header or something? This is more of a question to the room, but I feel like there's an API here that a lot of different working groups might use.
So I'm open to have this discussion, but like one of the decisions we made early on is that we want to keep the changes to the base spec minimal, right? And that would be a big change.
I just think when we start making copies of every frame, like here's an ACK frame, but we put the packet space in it. Here's a flow control frame, but we put a packet space in it. Not saying the spec does that. It just screams out a little bit to me, but all right, off my soapbox.
Point taken. Question.
On this discussion of the complexity of single number space, I mean, I started experimenting with single number space very early. I mean, it was part of my original design a couple of years ago. And I did implementation of single number space and multiple number space to measure the complexity. The complexity of multiple number space is that you have to add a bunch of statements in your code to check whether this is the multipass or the single pass case. And there are more checks at that for multiple number space than for single number space. But on the other hand, the complexity of single number space is that you have to add a lot of structure in your code to handle that. And for example, you have, in my original implementation, the single space solution was 5% less efficient, about 5% less efficient than the multiple space solution. And I took that as a challenge, like, can I make them to be equally efficient? And the answer is yes, I could. And I did that in my prototypes. But to do that, I had to add a lot of code in the ACK scheduling path. I had to add a lot of structure in the store of packets to make sure that packets carried not just the packet number, but were also linked to the path in which they were sent, and that we can retrieve how many packets were sent before them and after them, etc., etc. Overall, that complexity, as Miria said, is much more than the single number space. So that's the reason why I did support, and in fact I proposed this unified proposal. If, I mean, the reason for the additional complexity is the need to support the zero-length CID case. And we need feedback from implementers there whether that zero-length CID case is actually needed with multipass or not. That's what we need.
Yes, so I think, that's the main question. And if people are having a use case for zero-length ID and multipass, it would be good to learn about that, maybe put it that way.
Yeah, it's what Google. I was just going to add that, I mean, a byte is fine. I mean, at least for Chrome and other browsers and such. But also, I think I'm not fully understanding the problem. It seems like if I can distinguish at the receiver which path I'm receiving something on, then I can decide to use a zero-length connection ID. And if I can't, then I need to use a non-zero length connection ID. And this seems true in the existing server deployments we have today, right? I guess I'm not understanding why multipath makes this actually different. Like if I can tell from the ephemeral port, like this is path A or path B, then like I don't need a connection ID. But if I'm a server, I'm receiving on 443 and I have 10,000 connections, then like clearly I need a connection ID to like multiplex them.
So it does work, but it just makes your scheduling and your acknowledgement code more complex to get it right? You have to decide which packet numbers to use on which part of the packet number space to use on which path. And that impacts a lot like how your egging will look like. It impacts your egg size. And you also don't really know what the other end is doing, like how often do they send eggs or not. And when you get the packet back, there's like ambiguity about ECN markings. Usually you don't know where the ECN markings belong to which path. So you have to, if you get an ECN marking, you have to reduce your congestion window on both paths because that's the most conservative thing to do. Or you have to be somehow smart about egging, but that's the other end that you don't control. And the same is true for egg delay calculation. Usually you will only be able to calculate the delay on the longest path. So that's what you have to cope with. So you cannot fill the shortest path delay and whatever. And you have to have logic for handling all of that to make it work nicely and I think correctly. I mean, like, as I said, if you only send like a few packets, it doesn't probably matter. But if you actually want to have a performant connection, it's not that easy anymore.
Yeah, I would completely agree. I was merely asking. I think I didn't fully understand why we can't have zero-length connection IDs with multiple packet number spaces. I think that's the question I still don't fully understand, but I can take it off.
Because you like that. Because you get the same packet number on both paths and you don't know how to handle it. Like you have to distinguish like where the packet number belongs.
But if I have two different sockets, then like I could just use the socket and be like socket A, socket B. I don't know.
So I'm sorry if I can. I think the issue is not rebinding. If you're not rebinding on the path, then so, there's a lot of ambiguity.
No, I mean it's also like this doesn't. It's. The crypto to encrypt your packet number, right, doesn't allow you to have the same packet number twice or like these kind of things. It just doesn't work, Christian.
Yes, it's exactly what you just said. I mean, is that if you have the same packets, I mean, if you have packets arriving with the same number from two paths, then you have to inject a path ID in the crypto to understand which key to use. I mean, and if you don't do that, then basically your crypto is broken. So maybe we should take it offline, and if people are interested, I could have a discussion with them on exactly the complexity that we encounter there. But I mean, or you might trust me, but I know you don't.
Donna.
Thank you. So it sounds to me like there's a fair amount of agreement on doing multiple packet number spaces. It also sounds to me like there's a possibility of considering what else we can. we might be able to actually. This is an issue that's been like, doing the rounds for quite a while. And we've got some experience here. I'm very happy. I feel comfortable and confident in saying that we can move forward, but that's my opinion.
Yeah, so the audio wasn't super great, but I think you say we should decide now if we want to support zero links ID.
Yeah, I don't know. Can you hear me now? Is it better?
A little bit, yes.
I turn off my video.
It's also in the in-room audio from here where I stand is not great for me. So like, yeah, I mean, as I said, as probably Jana also said, I believe, the question is really not about like doing one or the other, doing single or doing multiple packet number spaces. I think what we decided already is that multiple packet number spaces is the way to go, and single might be optional or not. So the question really is, do we want support for zero length connection ID? That's the question to ask. I'm happy to make a decision now. I'm also happy to like wait for a little bit more implementation experience, because we have like a few not super hard open issues, but we need the discussion. So it's like, we can decide now, we can decide next time, or sometime in between. But yeah, at some point we have to make a decision. Cheers.
Thanks, Miria. Just from me, with my chair hat on, but my opinion, this has been some good chat and some good engagement. Thank you, folks. We've taken the comments down about the potential consensus call. Look out for that. We'll discuss and follow up on the list if there's anything to be done. One question I've got, you talked a couple of times, Miria, about implementation experience, and Alessandra mentioned that the Quiche project is looking to do some work. I wonder if maybe at the next hackathon in November we should try and form another quick table and actually try and bring some folks to do some implementation and interop and create a target and maybe come up with some test cases. We don't need that answer right now, but if people are interested in that, let's try and take that discussion offline.
Lars is in the queue.
Yeah, Lars Eggert. So I'm not super closely following this discussion in Quic. But back when we did multipath TCP, the research, not the standard, we actually tried to do the single space, which we quickly found out you can't for TCP, right? Because if middle boxes along a stream see gaps in the sequence number space, they just break in all kinds of different ways. But that was the original intent, because we thought that sort of felt natural. And then we had to do the one space per path, and we sort of made that work. With Quic, right, we actually have the option of doing the single space. But maybe we have now enough experience with multipath TCP and the multiple spaces to see benefits that we didn't see way back when. But I kind of sort of, without, as I said, not having followed this in detail, I kind of sort of wondered that the one space back then that we thought would be the way to go wouldn't be the way to go here. But since I'm not implementing it, I'm not going to deploy it. Take that as you will. Thank you.
So I think you're talking about different packet number spaces here than we are.
Am I?
Yeah, because in TCP you have the on-path sequence number, and then you have this separate thing.
Right.
Yeah, and this is not the kind of packet number space we're talking about here. It's really like the on-path packet number space, and it's really like, do you use the same numbers on both passes, or do you use different numbers, the different set of numbers on passes, but it's the same element, right? It's not like in TCP where you actually have this additional number.
The reason we have the additional number is because we otherwise couldn't make it work.
So but what you wanted originally is to take the sequence number, the sequence number field and put multiple packet number spaces in that field, and that didn't work, and so you had to have a new field. Anyway,
no, we were going to use a single sequence number space across all paths with a single field originally. Anyway, I think we're digressing.
And that didn't work because of all the packets are out of order and these kind of things?
It means because middle boxes see gaps and they don't like that.
Yeah. Yeah, so we don't have that problem, but having those gaps is also not optimal for the internal processing. So it's possible, but not optimal. Jana again.
Hi, hopefully can you hear me reasonably? I'll shut up if you can't hear me.
Yeah, it's a little bit better for me now. Yeah.
Okay. Lars's point, Lars, yes, exactly. I think that the difference here primarily, and so I'll also speak about not just MPTCP, but even about almost 20 years ago, I did this for SCTP. I've used SCTP multipath implementation. And there were reasons that we did that. And those are exactly the reasons that don't apply to Quic. Specifically, both SCTP and TCP had assumptions about linear sequencing. Both the protocols, the senders, the receivers, and middle boxes in the TCP case all have assumptions about sequencing of packet numbers. We don't have that in Quic. And so that's actually a freeing thing. In implementing this with single packet number space in SCTP, one of the things I quickly found out was that eventually near the end meaning after a while of working and implementing this, my conclusion was that separate sequence number spaces would actually have made things far simpler. Because a lot of the things that a transport does, recovery, condition, all things that are happening on a path, and there is a general assumption about sequencing on the path. And a lot of these mechanisms that we build and we deploy have those assumptions baked in. So if you move to if you move to multiple packet number spaces, those mechanisms just work. With a single packet number space, you have to go revisit every one of those implementation bits, and you find we typically tend to build a certain amount of reordering tolerance within a path, but multipath sort of really blows this out of the water. And you don't want to use the same ideas of reordering tolerance to multipath, because in multipath we have a lot more information. We actually know that there are two or multiple different paths within which we can expect a certain amount of sequencing. So all of that to say that multiple sequence numbers actually make it explicit what we're trying to do. That was NATs. In the SCTP case, it was backward compatibility. It was the fact that ACK compression wasn't very good when you split the sequence number space and so on. In Quic, we explicitly and deliberately allowed for those things to exist. And by design and by philosophy, we've allowed for multiple sequence number spaces to exist. And so I strongly urge us to go towards that. And if only things are falling apart badly, should we consider single sequence number space?
Yeah, thanks. That's useful input. And actually, Lars, we already have two sequence number spaces in Quic. One is a packet number and one is a frame ID, right? And that makes it nice to actually have this split and use a multiple packet number space on the packet number. Jonathan just disappeared.
Yeah, we're kind of at time. I locked the queue just so we can make progress and not spin too many tires on this question. If anyone really wants to say something, do so now. Ian, no, not Ian. I think Ian. Yeah, I think this has been very helpful, and thank you all for your inputs.
Yep, definitely. Thank you.
you want to drive the slides, or can I drive it from my laptop? Do I just?
Yep. Yep.
There.
You're doing that, right?
Yes. All right. What do I have to do? Just keep hitting the button? Maybe, oh.
The quick time is stamped, right?
Yep. Oh, no, that's right. Back frequency.
What is that?
Oh, last one. There. Thank you. I'm Ian Sweat. I'll talk about ACT frequency and give an update.
You can try that. It's working.
Yeah, this is designed for the mobile. Great. So there were some updates recently, mostly editorial, as well as some additional normative text in areas where there really was intended to be normative text, but we never actually bothered to write anything down, such as with ignore C. So this is an overview of the two frames that we have. The ACT frequency frame that allows you to tell the peer how often they should send acknowledgements to you, how long to delay them, so on and so forth. And then an immediate ACT frame that allows you to elicit an immediate acknowledgement. So I'm going to try to go through these in order of what I think will be easier to resolve issues first in hope of getting some resolutions, and leave the thorniest one to the last. And if we don't get to it, then I'm happy to take it up on the list. So the first one's an easy question. Should this be a 1 byte frame type? We probably want to stick it with PTO packets in a lot of cases. So I guess it's slightly more likely to fit. If it's 1 byte, we might want to send it reasonably often. This is a issue filed by Martin Seaman. What do people think? I see a thumbs up and a thumbs down. Would people like to give their thoughts? Or I'm honestly not sure how to resolve this. But
Sorry, I just left the meeting, so I can't press the button. I think it depends on how often you expect to send this, right? And that's not super clear to me. But like, if you send it often, it'll be 1 byte.
Go ahead. I mean, I'm still. Go ahead.
This was me, equivalent.
David Skenazy, who clicked the button faster. Come on, Martin, you got this. Like, we only have like 60 of the short byte packets, and extensions on average might need 1, maybe sometimes 2. We're going at a rate of 1, maybe 2 extensions per year. So we're not going to run out anytime soon. I would say for working group extensions where it looks like the majority of folks are going to implement them, yeah, get a 1 byte code point. Done.
All right. Thanks.
Yeah, so Martin Thompson, I've implemented this, and the number of times I send one of these things is vanishingly small. And I have stats to show that the number of times we send PTOs in practice is also vanishingly small. So I don't think an extra byte is a problem here, and I'd rather see it left as it is. I realize David's argument is a fine one, and we do have space, but I mean, we also don't have to use it. So leaving it as it is fine with me. By the way, the stats are like, we don't get PTOs on like 80+% of our connections. It's crazy.
Yeah, when the internet's working well, you should not be getting very many of them.
And it turns out it works well most of the time.
Okay.
John.
Did the chairs have any suggestions on how to? Oh,
John is in.
Oh. Martin, yeah, John is next, sir.
Jonna?
Jenna?
I'm trying. Trust me. So
we can hear you.
This I don't. I wonder if this is again one of those trying to optimize it well before we really have a problem here situation. I think that we should. I mean, we can go with 1 byte. We can go with 2 bytes. It doesn't matter much. I would suggest that we leave it as it is until we have more experience from various folks, and we can always come back, revise the draft, come up with a new version and stuff of that sort. At this point, getting this out and getting this into people's hands is more useful, in my opinion. So the leaving it as it is what I would suggest. I agree with Martin's comment that this is not something we expect to send very frequently. If you're asking immediate hacking to happen all the time, it seems like there might be a problem somewhere else. But yeah.
Martin Duke, Google. I would suggest that we are approaching bike shed territory on this, and probably nobody is going to lie down on the road one way or the other. So having gotten pros and cons, I suggest the editors just like make a decision, and I'm sure everyone can live with it. And if that's not true, then someone will correct me.
It's been pointed out that I didn't properly state my affiliation last time, so sorry. David Skenazy, Quic enthusiast. I stood up to say something similar to what Martin said. What a beautiful bike shed you have. I really wonder what color it should be. So yeah, I'm not going to lay on the tracks here. I don't care that much. Have the editors pick, move on. That sounds great.
Okay. How about we have Martin talk, and then I might actually just shelve this for a few months and just get some more utilization in different use cases of immediate act as well. But Martin?
Yeah, so sorry for opening up this bike shed. So the reason I opened this issue is because the draft says that there are some cases where you want to send this frame at least once per RTT. I'm not fully sure if I understand why you would want to do this. Probably we can add some more text about that. If you actually only send this on the PTO, then I don't care. But if you send it once per RTT, this might be worth doing.
Yeah, that could probably use more text. I think the idea was if you wanted more fine-grained control over when you received acknowledgements, it's particularly if you were using particularly long act delays in terms of packets and time. But yeah. Okay. Thanks. Let's move on. So there's a lot of discussion in various PRs about whether ignore CE is useful, or one could say harmful, but Miria was very kind in her issue title. It's also been restricted a fair amount. So it now says it should not be set if the sender sets ECT1 in its outgoing packets, such as for L4S. I think at this point, I don't think anyone is using this. And so I can see an argument that given it's not seeing active use, we should just jettison it because we don't need it right now. And I'm not sure I, as an editor, want to spend a bunch of time like arguing for ECN features that I'm not going to immediately use. But before we remove it or something, we didn't have a consensus call to add it. So I want to like bring it here and just ask, like, what do we think?
So Martin Thompson, I'm not going to be using this in the foreseeable future, but I can understand why other people might say that they would like to do something like this. The question that I have for those people is if you're doing something like L4S or planning to do that, would a transport parameter suffice in this case?
I might have a similar point. So like, I personally think the answer is no, but that's not my main concern. My main concern is that I think actually this shouldn't be part of this specification because it really depends on the congestion control and the ECN mechanism to specify what's the best thing to do. And so like you shouldn't have a need to signal that because it depends on like the algorithm you're implementing to do the right thing. and not the other end telling you to do it.
Does anyone have any other comments on this? Nope. Corey. We can't hear you, Corey.
Can you hear me now?
Yes.
Good.
Yes.
So we don't currently have an ECN method in the transport area which allows you to ignore CE, except by just dropping in the packets. So this seems highly tied to the CE method you use. So I agree with Mira. The answer is we should not keep it.
So you said we should not need it? Is that what you said, Corey?
No, we should not keep this function.
Okay, thank you. Sorry, I'm getting echo from, I don't know, maybe
Yeah,
it's just the speaker spot.
It's bad audio. Yeah, it's also like if you want to do it right, then it would be more complicated than that. So because you should kind of never ignore the first CE, but you might not react to like follow-up CEs immediately or whatever. So it's like this is also too simplistic to make it useful.
Okay. It sounds like I'm inclined to remove it, given where we're at. We can always add it back later if people decide that there's a compelling use case and actually want to implement it. But I do not want to ship a draft where we have a feature with no one who's implemented it. Oh, Jana.
I agree. I was coming up to say that we can use the transport parameter idea for Martin if we really want to do something here later. But I agree. When we put this in, just to be clear, we weren't fully certain how much traction this would get, but we kind of put it in, expected, thinking that there was an ask for it, and like, sure, we have ignored reordering, so we wonder if we should have this as well. And so yeah, if there's no strong push for it, we shouldn't add features that don't have people asking for it.
Cool. Thanks, Jana. Okay. The next one is kind of a can of worms, unfortunately, not from a design perspective, but just it's a challenging problem, which is exactly how much text do we want to put in there about examples or suggestions of how to use this extension. There's one open issue, but there have also been other side comments, particularly in the context of like Reno or Quic, about what is the right number. Like, is it 8 acts per RTT, or like what magic number do I need to stick in there to get like decent performance out of like Reno and Quic? And I honestly don't have a really good answer off the top of my head. But I guess the real question is like, what should we be attempting to do here? Like, how much more text or less text do we want about providing guidelines on how this actually should be used, potentially with congestion controllers that are widely deployed? So.
Martin Seemann, given that RFC 9002 specifies a congestion control algorithm that should be safe and performant for the use on the public internet, would be really nice if this extension also suggested something that will be safe and performant on the internet. Not saying that you can't do something better, but it would be really helpful to have something in that text for people who don't have a internet-wide deployment to run their own measurements.
As a follow-up question, because I don't have this off the top of my head, does anyone have a set of constants that they've used with Reno or Quic with the act frequency frame that they find work well? Or is this something where I need to go run some experiments and try to like get some data? Because we currently run BBR by default at Google and currently don't have any Quic or Reno experiments. But we still have the code, so we could go back and run those if that was kind of the way forward on this.
So I was going to jump in here, your hat off, as someone that has been thinking about experimenting with this with an internet-wide deployment. I don't think that we should put anything, or rather have the onus that this document prescribes something, because I think if we have that requirement, this is going to potentially be blocked on publication for essentially an indefinite period of time, because the answer is we really don't know what to do here. I don't think anyone has experience using this successfully yet with a variety of congestion controllers. Certainly not the one that we specify in the base draft, which is not really being widely used. And so my personal opinion is that this document can serve as a mechanism document, and if people have strategies that they want to use that they find success with, those can be follow-up documents that are specify, hey, this is how you can use ACK frequency for this. This is how you can use ACK frequency to achieve this. Because even with a single congestion controller, you're not necessarily going to have the same strategy. So for example, if you want to use Quic with ACK frequency in a data center versus Quic with ACK frequency on like the internet with a very low latency network on the internet, or high latency network on the internet, I think the strategies are going to vary, and we don't know at this point what those strategies are going to be. At least I'm not aware of any.
Thanks, Matt. Corey?
I guess you knew I was going to say I10 is 10 packet. That gives one further feedback. So 10 is not a bad number to kick out on for a starting point. It's probably a bad number in the end. It's probably a bad number in a data center. It's probably a reasonable number for an internet path. Can we just see what we can come up with here and see if we can make a recommendation before we publish of a starting value from which we can work for that we consider safe? Because surely 2 is very conservative, and surely an RTT's worth or 2 RTT's worth is highly controversial. So we must be able to say something. I suggest we work on it.
Okay. Thanks, Corey. Yeah, I mean, there are some boundaries, I think, about like trying to get an ACK every RTT typically and such, just for guardrails, but that's about all that there is right now. Okay, why don't I just keep this open and we can work on it over time. It doesn't seem like something we need to fix today. Thanks. Okay. So this is one that we talked about quite a while ago. A number of other people have looked at the PR again. How much time do I have left, by the way? How much time do I have left?
You have about 5 minutes, Ian.
5 minutes?
About 5 minutes.
Okay, thank you. All right, so we can at least go over this again and swap it back in, and if we don't get to the end, that's completely fine. So this is the idea of, okay, so one ACK is sent immediately upon a missing packet. However, the next ACK, say you have one missing packet and then 10 packets in a row arrive, and you set 10 for your ACK eliciting threshold, then you'll get one immediate ACK, and then you'll have to wait for the other 10 packets to arrive, and then you'll send another immediate ACK, and then you'll finally detect that like missing packet was lost, because if it's threshold based and it's a threshold based loss, say you start out with the last threshold of 3, the first ACK wasn't enough to immediately declare the packet as lost, and so you have to wait for a timer. And so timers can be relatively slow, especially in like low latency, like data center sort of applications. So this can actually substantially delay loss detection in certain situations versus the base draft once you start bumping up the ACK eliciting threshold. So anyway, the potential solution to this is to communicate the reordering threshold to the receiver instead of just saying ignore order. And then the receiver sends an immediate ACK whenever there's a missing packet in this range that basically would allow the sender to immediately declare loss. So it's basically an optimization as well as kind of a safety mechanism to say, I'm going to declare loss at this many packets. And so whenever you see, a missing packet that is in that range, and so that would allow me to immediately declare loss, like send me an ACK immediately so I can like do that as quickly as possible. is basically what this is saying as a mechanism. It slightly reduces the number of acts when packets are also received out of order. Because if you get a twiddle, one swap for the other, instead of sending an immediate ACK and then sending another immediate ACK when the gap is filled, you don't send the first ACK and then the gap gets filled and everything's fine. So it turns out for reordering on the internet, twiddles I think are something like 60% of all reordering. It's some huge number, at least last time I looked. So there might be some small performance improvement in low scale reordering on networks. But anyway, that's an overview of the issue. Especially now that we have dropped, or going to drop ignore CE, we have the bits to, make this like a 1 byte number, which seems like a sufficient amount of granularity, or we can just make it a var int. It doesn't really matter. So,
if people have comments, please jump in the queue now. Otherwise, we can move on. But thank you, Ian.
Okay.
No, Jana.
Jana? Jana? Miria, do you want to go while Jana's figuring out his audio?
Yeah, because I have a very quick comment. Yeah, cool event. So to me, this seems more useful than just ignore order. But I also didn't review the whole discussion on the GitHub issue. I will do that.
Thanks. That's my take as well.
Jonah is not there.
Okay. Thank you very much for your time, and I think I will give my.
Thank you.
Hi, I'm Martin Duke from Google. I have no slides, but I'm here to talk about QuickLB. Jana, did you want to have a comment for the previous talk? No. Okay. Very good. So the authors for QuickLB are pleased to report that all GitHub issues are currently closed. If you're interested in that, I invite you to look at the changelog or the submitted closed PRs there. The only one that probably worth at least bringing up is related to the crypto review that we received on the 4-pass algorithm. So this is the short CID encrypted version. There was a simple fix that they suggested that we made. There was another fix. There was another suggestion to kind of the best practice would be to make it a 12-pass algorithm. We declined to do that for reasons that are probably obvious. And Christian submitted a PR. Thank you, Christian, that explained the reasoning there in the security considerations. I invite you to look at that email, file an issue if you have a concern. And if you have any questions about that now, I'm happy to answer them. What I really wanted to talk about is just the future path of this document. As I said, we've kind of reached the end of our editorial process as far as we can do it. So one option is just to go to working group last call. Which will of course generate more issues, but basically expedite moving the document forward. The second option is to wait for some more code. The current implementation status is that there are, to my knowledge, 2 load balancer side implementations. One is mine based off of Nginx, and there's one from Ant Financial. There are a couple drafts out of date, but because they're both load balancers and no servers have implemented at this time, we cannot interrupt because we need both sides of that interaction. I am currently, my current and my day job is to implement QuickLB for Google Quiche on the server side. So we will have a server implementation soon, and also probably, certainly within the next 12 months to deploy this at Google. So option 1 is working group last call immediately. Option 2 is to wait for that implementation deployment process to continue. And then working group last call. And option 3, I guess, would be to wait for more people who are not Martin Duke to implement this thing, but who knows how long that'll be. So that is all I have to present, and I would love to hear comments from the community of what they would like to see before we working group last call. Jonathan.
When my audio comes up. Yeah, Jana wanted me to relay because he has audio trouble. About the difference between ignore order and reordering threshold. If you want to retain ignore order, please speak up now. Otherwise, reordering threshold is likely the direction we'll go.
Okay, so that was a comment for Ian, I guess. Do you have a response or? Okay, that was about the reordering threshold, right? Or okay.
Yeah, I know the audio is very bad over there. He just said, like, if somebody wants to keep ignore order, please speak up now, otherwise we will switch.
Okay. Wearing someone else's document, but I don't see anyone commenting. Nobody in the queue. So, all right. So returning to the question, does anyone have an opinion about the maturity of the Quic LB document and its readiness for working group last call?
Yeah, cool wind again. I don't have a concern to go to working group last call right now, but if there's like no good reason that we need to publish it immediately, why don't we wait for your implementation?
Okay, I'm seeing thumbs up, a sprinkling of thumbs up with that sentiment, which is fine with me. So you will probably not hear from me for a while about this document. Like I will do another report once things are a little more mature at Google in terms of doing this work. And retry offload, just while I'm up here, is in a similar stasis state, but there's no active implementation going on. So that is sort of in the deep freeze until somebody is shown to care. Are there any other questions for me or comments? Ian.
Ian Sweat, Google. I had a question for the group, actually. I was curious if anyone else besides you at Google is working on a Quic LB implementation. Oh, Eric Kinnear is getting up.
Eric Kinnear, Apple. I don't think we have plans to immediately deploy anything, but we've certainly been looking and trying to provide feedback as we go and need something with a very similar set of attributes. So I would not give up hope.
And I would just like, while I'm up here, make an appeal to like server implementers that, I mean, one of the intents here, like the original target use case for this was the cloud, that cloud L4 balancers would implement this, and then, you know, people could deploy Quic servers and they could all interoperate. I think certainly our long-term plan is to do that in Google Cloud. So, you know, I think those of you who are trying to position your servers, like this might be an interesting market opportunity. Anyway, if there are no other questions, I'm going to return the balance of my time to the group. Thank you.
Cool. Next up, we have Christian talk about quick timestamps. As we enter the phase where we stop talking about adopted work items and talk about related or potential new work.
Do you want me to present the slides, or can you do it?
You can take remote control, Christian, if you would.
Okay, I did not expect that. I'm sorry. It take me some time.
We can do it if you prefer.
Yes, please.
Okay.
Christian, the slides are uploaded. You just have to click the request button, and then you can control them. You don't have to share your screen.
So what is the request button?
The request slides, just click it and select your slides. Looks like a piece of paper, the other people say. It's a second, I think it's a second from the left. Just click it.
No. Second from the slide. It's not visible on my screen.
There's a raise hands and then the next one to it.
Oh, that one.
Yes.
Yes.
There you go. And now you can select your
Ah,
sites.
you know, one learns every day. Yeah, here we are. Share. Good. Okay. So timestamps. So what for a timely talk? The question is, shall we work on it? And I have been working on the timestamp project for some time, and it has not been progressing very much because, I mean, some people did implement it, but apart from Quic, and I believe the Lightspeed implementation, I have not heard feedback. The first design of the timestamp was to solve the asymmetric case in which there is high bandwidth available on the send pass, but limited bandwidth on the or congestion on the return pass. And the failure mode there is that you can often observe congestion on the global pass where it's only caused by the return pass. And the response shall be very different. So with a timestamp, what happens is that the acknowledgement are sent in a packet that is timestamped, and the congestion controller can use that timestamp to understand which way the congestion happened and trigger different reaction. And that suppresses things like wrong RTT measurement or wrong decision congestion control, or even spurious retransmissions. So that was one use case for the timestamp. The next use case for the timestamp is clearly for multipass. In the case of multipass, we have configuration in which we have one high bandwidth pass with a relatively long RTT and one low delay pass with a slightly smaller bandwidth. What we see is that if we send acknowledgement through the short pass, that's not the pass on which the packet was sent, we improve responsiveness, we get better congestion control, we get better loss recovery, but we need to have a smart way to measure the actual RTT of the pass that combines half delays one way and the other. And a comment I received on that implementation is that it requires a PhD to understand you do RTT measurement. Well, I don't think it does, but then I do have a PhD, so who knows? The timestamp option fixes that very cleanly, because I mean, if you have a timestamp in your packets, you can measure each half delay each way, and then the implementation becomes completely straightforward, and it's much easier. Now, there are other use cases for timestamps. I mean, they are very useful if you do delay-based congestion control, things like lead-bat, for example, but also high start. I mean, if you use timestamps during the high start phase in Quic, you will very quickly notice the increase of one-way delay that high start relies on. And so I think that there's a strong use case for having timestamps in Quic. Now, that draft I have is at version 10. It's a very simple draft. I mean, it just defines a timestamp frame with a type, and the timestamp has a number of microseconds. And an enable timestamp transport option, which is basically what you find for every extension, the couple of a frame, and a transport parameter to negotiate its usage. I would think that given that it is very simple and there are well understood use case, we could take it on in the working group, but it has been a long time. And so since that is a long time, my question there is, what next? I mean, there. Shall I go ride against another windmill, or maybe just enjoy the sunsets? Okay, we'll not leave you on that, leave you there. So next step really is, does the working group want to adopt the draft? Does the working group want to discuss it? Maybe it's not the right way. Maybe we need something more complex than a simple timestamp. There was a proposal to completely change the ACK format so that we can have a delayed, an ACK delay on each packet. We could do something a bit more complex at NTP, which has basically 3 parameters: I mean, the sender timestamp, the last received timestamp, and the delayed since the last received, which makes measurements even more precise. But at that point, I am really wondering whether we should pursue this or not. So, questions? Xuanma is your turn.
Xuanma.
Yes, here. Can you hear me? Hello,
Yes.
everyone. Hi.
Yes, I
I'm
hear.
Martin from Tsinghua University, and I'm a newcomer of the IETF, and I'm really interested with the Quic working group. And our group is also working on adding timestamp to the Quic. So I think it is really important to add some timeliness signature like timestamp to the Quic mechanism. But I think there are really something that we need to have a discussion, and some implementation should be more discussed in detail. Let's say, firstly, is it mandatory for the sender and the receiver to do the clock synchronization if they have to, let's say, generate their own timestamp, or is the timestamp is only generated by the server itself? If the timestamp is only generated by the server itself, so the timestamp cannot be used by the client to tell something about the information of the timeliness, but only to measure, let's say, the one-way delay from the sender side. So I think maybe some more specification may be included in the draft. And is it also necessary for all the package to contain a timestamp frame, or maybe some kind of package, let's say the acknowledgement, the package with the acknowledgement that needs the timestamp? So I think maybe some details may be specified. Okay, that's my opinion. Thank you.
Thank you for the suggestion. I think that at a high level, I agree with you that we should have a discussion inside the working group about what is needed and get feedback. And I think that's one of the reasons I'd like to see some adoption, so we can get these multiple people working together. On the issue of clock synchronization, we had a debate on the structure of the frame. We had feedback actually several years ago that tells that the frame should be as simple as possible, and the document should only specify the frame, not the mechanism, because the mechanisms will be the combination of, say, that frame and the acknowledgement frame, etc. But I mean, at a high level, yes, we should absolutely have a discussion. Ian?
Yes, Ian Sweat, Google. I was a co-author on one of those documents that you mentioned about multiple timestamps or timestamps per packet, and that is not being actively pursued by us right now, except we do have it implemented for one internal project, which has a very non-standard congestion controller that I think actually got published at some point. I could dig it up, but it's kind of in this weird state where we basically just published it just so it was kind of out there. But it's not something we're actively pursuing. I will say, just from an implementation perspective, it's a lot more convenient to like be able to curry the timestamp in when you receive an acknowledgement. Now, there's a number of ways of like making that happen in the code. Like you could store the timestamp and always have it received like right before the act or something like that. But like just from a code structure perspective, having the timestamp available, even if it's only one timestamp at the same time that you're processing the act is super convenient from a code structure perspective. But I guess I don't think you should give up on this work. I don't have really good advice on what to do next, unfortunately, but those are my experiences.
Yes, I mean, I do agree with the fact that that's what we have in the Pico Quic implementation, that the timestamp is always sent together with the acts. But yes, Martin
Duke, Google. So I believe I understand the case for multipath, but I'm not sure I understand the justification for single path benefit. I mean, if you detect that it is like reverse path ACK congestion, would you like send more aggressively and just make the ACK congestion worse? Or what is the response if you obtain this information in the single path case?
Well, one way would be to tune the ACK frequency, for example.
Okay.
But also the other way would be to understand that you can avoid spurious. I have seen two usage: avoid spurious retransmission, and in high start, avoid exiting high start too early because of events on the ACK path.
Okay, I mean, I'll have to think through that. I'm sure you've reasoned about it correctly, but thanks.
You know?
I think John is maybe having some audio issues again. I'll dive in with a simple question. There's some talk about time synchronization stuff. That sounds super complicated. Like, I think starting with something simple, if we were to do this work at all, but starting with something simple wouldn't preclude more complicated stuff coming in the future. We have space for extensions and frames. Like, if there's some usage of this thing, go that way. You're sure some specifics could change, but I'm seeing a few use cases, and this is without a chair hat on. With the chair hat on, I'd really like to understand if people would really object to this kind of work. Like this isn't adopted, but we'd be seeking a clearer idea of if we should be seeking adoption or not for this work, because it's been kicking around for a long time now. I think we need to make a decision what to do. Thanks.
Jay Collin. I think that there are some good use cases for this. You can apply this to do like chirping and find and apply some of the path dispersion bandwidth detection techniques with this. And do we need it? I could use it, I think, but so I'm broadly supportive, but I would, I guess, like to see some development in the use cases, maybe, to kind of get a better handle on other ways people anticipate using it. But yeah, I think to me this looks useful. Thanks. Bye.
Jonathan Lennox, I mentioned this on the Zulip, but I'll repeat it here. I think this would be useful for a lot of the real-time media cases, all the RM, or most of the RMCAT style feedback mechanisms, most notably Google CC, which is the congestion controller in libobrtc, use timestamps for one-way delay to get the low delay real-time media congestion. So I think if we want to, for a lot of the use cases where we're going to do either RTP over Quic or media over Quic, I think this would probably be a useful thing.
Yoshi Nishida from Amazon Web Service. I'm not very, following up quick discussion, but so I'm wondering about measuring one-way delay for high start, because high start is synthesized logic, so you need to receive back anyhow. So unless there is a condition on the ARC path, I don't know if the measuring one-way path is that useful. Maybe we might want to see more use cases.
Spencer Dawkins. Christian, am I understanding your ask is about adoption of this draft in the working group? Is that right?
Yes, that's really the case. I mean, because I don't want to be continuing to push a draft and there is episodic feedback every 2 years.
Yeah,
if
sure.
it is adopted by the working group, then I'm going to continue working on it. Otherwise, whatever.
Could I ask the chairs to help at least me understand what the bar that Christian should be looking at for this is? For adoption in the working group? I mean, is it close enough for you all to call and say who's interested?
Speaking as chair with my hat on, I think having this discussion at the session has been good. Some of it is knowing if the author wants to seek adoption at all, if they feel ready. I'm seeing generally positive comments, like that this could be useful, especially because of the format and that it could apply to different things, but then a few people saying they don't quite understand the use cases. I think what probably needs to happen is a little bit more follow-up discussion on the mailing list, and that probably I need to confer with Matt as well, but I'd kind of be leaning on issuing an adoption call just to flesh out people who would strongly object to adopting that work right now, and the reasons why, and therefore, if those reasons are things that Christian wouldn't want to address, then he can go away, and maybe in the future somebody else can come and pick up this style of work. That's what I'd be looking for. Does that make sense, Spencer?
Yeah, yes, it does. So the other thing I'm thinking, I think Jonathan Lennox and I were headed the same place, roughly, which is as we are, like AVT Core has just adopted an RTP over Quic draft, and we had a media over Quic buff this week that was not as much of a train wreck as it could have been. If especially if that second chunk of work gets chartered between now and November, I think it would be, I would like to see an adoption call go out sometime between, like I say, roughly when it seems right to the chairs. But I know which way I would hum on an adoption call, but do the right thing, of course.
Thanks. I also see there's some discussion in the Jabber that I've been trying to keep up with. We'll take on board these comments, and Matt and I will have a discussion, I think.
All right, you have the one from Jana. The big one from Jana.
Yeah, Jana had problems joining, not joining the queue with the audio, I guess. So we can
Yeah, so
we can read it ourselves.
yeah, I can read Jana's comment. Let me put it back in front here.
Or I can just read it out loud.
I lost it. Yes. So Janan is mentioning that there should be work on the variation of the one-way delay, which is correct. I mean, all the measurements of delays over the internet are uncertain in the sense that you don't know which the reference is exactly. So you never measure absolute delay because there is all your equations, all your system of equation end up undeterminate, and you have to make an arbitrary choice of whether the delay is one way or the other way. What you do measure then are the variation of the delay, and that is correct. And we could go explaining that. It's kind of obvious too, but it's the kind of stuff that I would like to see after the adoption, because clearly that could be done by a PR in the draft and a discussion. And I don't disagree with Jenna, that's what actually use, but yes, I mean, I think I'd be very happy to work with Jenna if someone is actually working on this and wants to improve and want to become a co-author or something, I'll be happy to have one too. I mean, it's not like I want to own that thing.
I think my audio might be working again.
Okay.
Oh, wow. Okay. Awesome. Sorry. Yeah, I agree with you. I to clarify this because I think this is a point of confusion oftentimes for folks. Just calling it one-way delay delta makes it clearer. However, I think my higher order point here is that I think the draft is useful because it allows people to actually have a mechanism to experiment with. But without actually having a lot of people asking for usage of this thing, it will be difficult to design a mechanism that's going to be worth standardizing. That's my opinion. I think that we need people with use cases before we can actually adopt and standardize something.
Okay, thanks, Jana. We're at time for this item. Like I say, we'll go away and do some discussion with various people. This has been very useful. So thank you all for the comments. Thank you, Christian.
Thank you. Thank you.
Next up is Jake Holland.
Hello. I got slides.
You're running it?
Huh?
Are you running the slide?
I don't have any means to run the slides, do I? Oh, on my phone. Is that the way I'm supposed to do it? Could you bring them up if that's possible? Thank you. Great. Yeah, hi. I'm Jake Holland, multicast enthusiast. I'm here to talk about our multicast Quic proposal. So I'll just be mainly going over the actual proposal. If you want to see why I went over that, there was a barb off at the remote 111, and there's links to that in the slides there. We also went over a little bit of that, went over a little bit of it in sec dispatch at 112. This proposal is largely a follow-up to that sec dispatch 112 discussion where some of the feedback we got is that we needed a specific protocol proposal for the security characteristics we were looking to get with our multicast security consideration stock that tried to go over the security considerations for using multicast to deliver web traffic specifically, but also for generalized non-web traffic delivered over multicast. So that's what I won't go in depth, but I'll just try to give a kind of really basic overview. Next slide, please. Is that next? Thank you. So the basic idea is we're just supporting source-specific IP multicast. This is anchored to a unicast connection. So there's always a unicast connection between a server and a client, and then the server can tell the client, by the way, some of the data that I'm trying to send you, the way you should get it is you should join this multicast session. You'll see some 1RTT Quic packets there. Here are their keys to decode obviously, since it's multicast, the packets are identical for every receiver. These are shared symmetric keys. That's one of the things we get into in the security consideration stack. That's essentially the security consideration section for this document. Because they are widely distributed shared keys, we also have separate integrity packets that are anchored on the unicast connection that mean that even though the keys are shared, the packets cannot be spoofed. They must be proven to have been sent by the actual server that you're talking to. The server controls the entire sort of multicast listening process on behalf of the client. They tell the client what to join. The client's not required to join these sessions, but may join in order to sort of get a better delivery scalability. The client provides limits. So all the flow control and congestion control is different in a way sort of dictated by the requirements of multicast. And we go over some of that in the document, but some of it is sort of why we're proposing this as experimental at this time. But what the client provides is some limits that the server is responsible for staying within as it tells the client what to do, right? And the client sends ACKs for all the packets that it receives. And this is very similar in a lot of ways to the multipath work. The packets are just interpreted as a part of the unicast connection that you've got. It's anchored on a client, on a channel ID rather than a connection ID, but that's essentially just a layer of indirection to the connection ID. And the reason for that is basically that, again, it's shared identical packets that are sent to many receivers, and so the server has to choose that destination connection ID, essentially a connection ID. But that's a channel ID in the place that the connection ID goes in the multicast packets. And the unicast frames communicate what those channel IDs are. All right, next slide, please. So the multicast channels are only for server to client data, only for server initiated streams, essentially. It can be used for datagrams as well, not so much for web traffic because H3 datagrams have a client chosen ID inside them. But for non-web datagrams, it still should be possible. For server initiated streams, it also, we think, is possible. And the packets are just interpreted in the context of that connection, of the unicast connection that you already have. Yeah. Any questions about any of this? I'd be happy to go over, but let's just move on for time here. Again, for discussion, yeah, next slide. For discussion, so we're working on an implementation. This is in conjunction with several members of the W3 multicast community, W3C multicast community group. We've been basing it so far on the Google Quic implementation, working toward a demo that could run in a browser, but you know, we just want to prove to ourselves that it will work, essentially. But we think that it will. In terms of implementation status or the maturity of the spec and what we think we've solved, we don't know of any reasons that this does not match the security considerations document, but we do think for web traffic, we've recently noticed that we probably need to include something that more strictly enforces the origin policy or allows the browser to enforce origin policy on the multicast packets that are received. We do think this is possible. We have a couple ways to do it. That's not yet part of the draft, but because the packets are integrity protected and can't be spoofed, we think that, for example, we could include an origin frame in the multicast packets, and this would give the browser the information it needs to avoid including anything for a wrong origin in the data that's processing. So we don't think that this should be considered mixed content, but opinions may differ on this point, and we'd be interested in hearing reasons why we might be wrong here. Next slide. We have a number of protocol extensions, and the reasons are basically all just driven by, we're asking for basically 10 new frames at this point. We outlined them in the draft. We have, this is part of the implementation that's working there. But there's essentially just management of the multicast channels in the unicast stream where the server tells the client about them, management of the client state, and then the acts that are associated with it. Plus the integrity guarantees that require a separate integrity path. And we can go into the details of all this. I'd be happy to talk offline as well. We probably don't have time for as detailed a discussion as what we saw in some of the more standardized pieces earlier in the session. But next slide. The basic question I've got is this interesting to anyone? We think that we can solve a big scale problem here. We certainly would like to deploy this. We're interested in deploying it non-browser at first because we've had sort of a skepticism, I think, from the browser community so far. But from the ISP community, we have, some consensus that scaling problems need to be solved. There's too many events that are sort of exceeding the capacity of the networks to deliver when there's popular content. This is primarily driven by popular sports and by large downloads. Most of the large downloads would not be web traffic, but the popular sports often is, particularly when you consider that a lot of the smart TVs basically are using web APIs underneath. Something like 60+% and growing, last I heard. But in addition, various forms of browser apps and a lot of the clients actually are using browsers inside as well. So yeah, I guess my first question is like, does anybody think this is worthwhile? And if so, like, what do you recommend we should do before asking for adoption, or where should this go? And we'll be discussing this more in MBOND in the next session, by the way. So come there if you're interested, and we can get into it more. Alex.
Hi, Alex Chernowski, Google. I was looking over the slides before your talk, and I mostly had the observation that I feel like what you're proposing is not something that is in Quic, but something that could be built on top of either TCP or Quic with the type of control channel stuff that you're doing. So my question is really, is Quic the right place to do this? Or is this a separate protocol for here is how I want to join a multicast thing, and a separate framing layer for here is the multicast available data?
Well, we're looking for some frames in the IANA registries for Quic. Does it have to be Quic? No, I mean, you can have different multicast protocols. That's possible. We could do something that has the same security properties that's not Quic. Or we could have our own proprietary extension if we're going to be shipping fat clients. But we would like to aim toward an eventual something that can eventually be included in browsers. So that's kind of where I'm coming from with the Quic effort. Thanks.
Hey, Lars Eggert. So I like this. I like this already when Lucas came up with it a few years ago, and I'm glad to see that it's sort of being progressing. Because we always had this gap in transport, right, between the unicast and the multicast, and we could never sort of figure out how we can actually leverage the power that multicast potentially offers more easily for applications and for, users. And then this goes in that direction, which is sort of kind of exciting. I don't want to speak about the adoption call, but sort of in terms of what I would see, you think about is sort of how general a mechanism this could be. I mean, there's some obvious use cases, right, that are motivating this, but this is sort of the first time that we have an approach that mixes unicast and multicast pretty easily and efficiently. It would be great if it would be usable for lots of stuff. Thank you.
Yeah, that's a good question. I guess I would point to the warp and rush proposals. We think we can just do as is because these use server initiated data for pushing from the server side. So that's the demo I'd like to run. Inside a custom browser, is just use web transport with the existing thing, and it doesn't have to change the application at all. I think that server push based HLS or Dash could do the same thing. Although server push, I gather, is being removed from the browsers, unfortunately. So I'm not sure that'll be any better in the near future, but we could also like keep a fork that keeps the server push cache around and try it there for the same kind of thing. But yeah, we think it should be transparent for the apps. Yep, thanks.
Mike Bishop, I'm a little surprised that you're putting quick frames on the multicast stream. I would have thought the multicast stream would just be raw data delivery, and then the frames on the unicast quick session tell you what to do with it, basically.
So one of the actually nice design choices in Quic, the consequences of this are that it works pretty well to just put the quick frames on the multicast stream, and then use the same encryption strategies and use the same deframing. This is actually a very similar problem to like the multipath work, right? This is just you can have a stream that's partially carried on one path, partially carried on another path. They can be combined as long as they have the same data at all the same offsets, right?
Right.
So that's essentially what we're doing here. And
so you have a shared path on the multipath connection.
well, it's an alternate path for the multicast. The multicast channel is just an alternate network path that carries the same data. So once you've decoded it, then you merge it as part of the same connection for your packet processing, and you can have almost all the same behavior. It's just yeah, there are some differences in like flow control and congestion control. There's some differences in the connection ID versus the channel ID. But most of the packet processing is actually the same and works out pretty well.
Chair interrupt here. We're over time now. I'd like to thank everyone. Jake, sorry to interrupt you, but I think we got some feedback there, which is kind of good. I'd encourage hallway discussion for anyone that didn't make the cut. We had one more talk from Emil, which we didn't make time for. I apologize, Emil. This was in relation to a side meeting that was held yesterday. I believe some of the participants of the Quic working group were there. I wasn't able to attend, unfortunately. My understanding is this relates to quick observability, tooling, visualization, analysis. My kind of chair comment with a hat on is that's work that is completely related to Quic, and I'd love to see happen in the Quic working group where it makes sense. So I'd encourage that kind of thing to be proposed at the next Quic agenda, if it makes sense, and please speak to the chairs about that in future, and we can have that discussion a bit earlier, maybe. That would be great. I don't know if Matt has any closing comments. No. Okay. On that note, I'd like to thank our JavaScribe and note takers very much. I'd like to thank Zahed for being on the ground and helping with the delegation of responsibilities. And everyone, have a great rest of your week and a good lunch.
Thank you. Bye.
I've actually been talking to various folks about this for like, I think since like the Paris intro.
Yeah, I know. Lucas said it is, I mean, obviously didn't read it. And that's what how Lucas works, right? So it seems interesting.
It seems very doable. I mean, it's the thing I actually tried to get people internally interested in, and the YouTube folks are like in theory interested, but they're like, this doesn't work on almost any network right now.